30 items are arranged in a 6 by 5 array. Calculate the number of ways to form a set of 3 distinct items such that no 2 of the selected items are in the same row or same column. So one way to do it is that we have to pick 3 items. Now there are 30 ways to pick the first item. So let's say we pick A1 as the first item. So once we've done that, you're not allowed to select anything from that row or from that column that has A1. So if you look at this, these are 10 entries. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Don't count this twice. So there are 10 entries gone. So it means that for the second pick, you have 30 minus 10 equals 20 choices. Okay. So let's say we pick A7 as the second pick. So then we are no longer allowed to use the column and the row containing A7. So now if you just count how many are left, 4 times 3, 12 entries are left. So it means we have now 12 choices for the third pick. So now 30 for the first, 20 for the second, and 12 for the third. That multiplies to give 7,200. However, the way we were counting, we will actually count the same 3 entries multiple times if we go in a different order. So for example, you didn't have to start from the first entry as so. Okay, one way, the way we were picking, we picked A1 as the first entry, A7 as the second entry, and a third, let's say the third entry we pick out of these 12 is A30. So we went A1, A7, and A30. However, we could have started our process by picking an entry A30 as our first entry. And then you're not allowed to pick anything from this column and this row. And I am allowed to pick A7 as my second entry. And that means the second time, so this row and this column is also gone. So see, A1 is still left. I can pick A1 as my third entry. So I picked the same 3 entries, but the way we were counting, it's counting this as 2 times. And in fact, there'll be one more, there'll be other ways also of counting the same 3 entries. So you can convince yourself easily that this way of counting actually gives us the permutations of the 3. And we want the combinations because if you look at the problem, we wanted the way form a set of 3 distinct items, and so there was no order. A set is unordered, and A1, A2, A3 need to be counted only once in any order. So the way we change permutations to combinations is through this formula. The combinations is equal to permutations divided by R factorial. So R is the number of items you are picking. In this case, we are picking 3 items. So the permutations was 7,200, and we divided by 3 factorial because we were picking 3 entries. And so that is 1,200, and that is choice C.